Hello, everyone. Today we're presenting our Netflix data analysis project, and our goal is to analyze user behavior and use machine learning models to predict engagement. In this presentation, we'll discuss the business problem, the models we used, data insights, model performance comparison, and finally, our conclusions and ethical considerations.
So for our main business problem, what we were working with was based on Netflix's black box analysis. There's kind of a summary we have here, but effectively, Netflix uses a black box data analysis method to build customer profiles. So whenever you watch a show, it adds that to your profile, kind of building on who you are. All of this is kind of in the air quotes because it's tough to really say for certain how Netflix does it due to their black box model, which means you just can't see what's under the hood effectively. But it uses the customer profile to determine their best next option. Um, and that best next option is based on all your previous titles. And so our analysis today was using two different data sets that we used to kind of build a replica of that model. Obviously, it's simplified. It's not the exact same system that Netflix uses because we're currently using something that you can actually see and look through the analysis for. But by and large, it uses a similar system to what Netflix uses. Um, in terms of our first model, we used a logical regression or a linear regression. It is a simple way of just discovering different outputs based on changing independent variables. As you can see, there's some of our statistical analysis on the side there. Effectively, it was a good way for us to get like a very grounded perspective on how the ratings, the weekly views, different variables within the data set would affect our output on how common or how often the model might recommend that as your next option. So say you take this title X, what's the likelihood it recommends title Y versus title Z? That's kind of what the first model we used was. It'll also allows you to see just basic data analysis for commonalities and patterns throughout the whole regression and the whole data set. So it was a very good starting base. The second model we used was a decision tree. We decided that this would be the one of the best models to actually see what the customer is looking at because you're presented with a handful of different options. A decision tree is fairly similar to that system, so it lets you say, "Oh, if you finished title Z, what's your likelihood of choosing title Y versus title X?" Kind of a similar system, but it's obviously using it based on very different variables, and it gives us a good output that we could later expand on in separate models. Um, if you'd like, you can take a look at the data there, but moving on to model three.
So model 3 is random forest. This model combines multiple decision trees instead of just using one. So it looks at different parts of the data and then averages the results, which helps make more accurate predictions. And because of this, random forest is usually more reliable than a single decision tree. Um, There is also another model we did. It's called comparative model performance. So we compared three models, logistic regression, decision tree, and random forest. We found that random forest performed the best with the highest accuracy, and the decision tree came next, and logistic regression had the lowest performance. So this shows that more advanced models like a random forest can capture patterns in the data better. But at the same time, simpler models are easier to understand.
So for our average and longest 2G by category, we analyzed the average longevity, which means how many weeks titles remain in the Netflix Global Top 10. The results show that the TV content stayed in the rankings longer than films overall. So in particular, TV non-English titles have the highest average longevity, followed by TV English titles. This makes sense because TV series encourage repeat viewing and audience return for multiple episodes, continue binge watching, and stay engaged over time. By contrast, films at lower longevity, movies are often watched once shortly after release, so they tend to leave the rankings faster. So the key takeaway from this chart is that series content appears more effective for sustaining long-term engagement. Next chart, please. So in chart, we compare average weekly views across categories. Here, the pattern is different from the before chart. English language films generate the highest average weekly views, followed by TV English titles. This shows that films are strong on attracting immediate attention when they're first released, and big movie launches can generate fast audience traffic and large global reach. So, although films often create bigger short-term spikes, they do not always stay in the rankings as long as TV series, and it shows that high launch popularity and long-term retention are not the same thing. So we can know that Netflix needs blockbuster movies for immediate buzz, visibility, and subscriber excitement. Next chart, please. So for this chart, we explain the relationship between longevity and popularity using a scatter plot. Each point represents a title. The x-axis shows weeks in the top 10, and the y shows average weekly views. So those titles are clustered in the lower left area, meaning that many titles have moderate views and shorter ranking duration. However, several outliers stand out. Some titles achieve very high weekly views but stay for fewer weeks, while others remain in the rankings longer with more stable performance. So for example, a movie may create a large one-week spike, while series such as Squid Game can combine strong views with longer-lasting popularity. So maybe Netflix success can happen in different ways, like short-term hits that generate immediate attention and long-term performers that keep viewers engaged over time. So Netflix should balance growth strategies by investing in high-impact movie releases and long-lasting series content.
And for this last chart, this is the average weekly views over time. As you can see, there are a few spikes and valleys in the chart. Um, Viewing volume changes over time. This likely reflects content release schedules, audience cycles, and shifting demands. So the ethics of using this data in any entertainment decisions, it can improve efficiency, but there are certain risks, like algorithmic biases may favor certain genres or countries. Over-reliance on data may reduce creativity. Viewer data must be handled with privacy protection. Predictive models should support and not replace human judgment. And the conclusion. Based on this analysis, Netflix should invest in genres with historically strong performances, use metadata to forecast likely ratings before release, improve recommendation systems using content patterns, and balance movies and TV series for growth and retention. Thank you.
These are our references. Thank you for your time.